Hello, we're going to talk about supporting information system here. Information, you can thinking about use computer to collect all the data, come up with information to help you make any decision. System here, computer system here. And supporting here for a specific use of computer system of the information. For example, as you can see, here is the hospital. The hospital going to use different type of supporting information system. Comparing to the bank, comparing to the military, they are all use different type of information system to meet their different need. How can we guarantee the information system is reliable here? Means they are up, not down most of the time. How can we guarantee the information system is secure? It's not going to have a hacker attack and steal or change the info here. That's security. Reliability, security, they are two key tasks, ongoing challenges for any information system here. Redundant here and fault tolerant. These are make reliability here, make you reliable here. This got nothing to do with security here. See, I have a redundant system here, so it's more secure. No, it's more reliable. One fail, the other one will pick it up here. Fault tolerant here, same idea here. Fault tolerant here, if I have a hardware here, they have some problem here, they will go back to original state and start all over again here. Bring up, automatically bring up by itself here. If you need human being to go there and bring it up, it takes time here, going to be slow here. You need to have some kind of fault tolerant system and redundant system here in case something happen. One portion fail here, the stand up, being brought up automatically here. It's like a hiccup here. The ideal situation here is the user cannot notice the difference here. So that will be like much less than 1 second here. The system will bring up itself here. That's talking about redundant here. Mission critical system here, that's a term for like police station here. They are 24 hours, 7 days a week, 365 days a year. For that kind of system here, you need mission critical here. So this is the mission critical system here in the hospital here. The hospital here, you cannot, let's say, hey, this is the midnight here, so the computer will be down for 2 hours here. You have patients there. It's not going to work that way. So how can you make sure this is like always on here? When we say always on, it's a goal here. It's perfection. It's hard to achieve here. So sometimes you may have downtime here. Say 2 seconds here, next month 3 seconds there. That is tolerable. It's acceptable here because you cannot really make it in perfection here. So mission critical. So what's mission critical? They give you some example. Mission critical means reliability going to be like almost on, and security, of course, here. You don't want people to steal your information out of a hospital, out of a police officer, out of military. I gave you 3 examples here. They are very, very critical, mission critical information here. The school here, a campus school here, it's not mission critical system here. For instance, if you have a campus school, you're trying to go to your school website, they'll tell you this is our maintenance time here, so nothing to work. Come back later here. A hospital system here, policeman system here, military system here, for example, cannot do that. They cannot do that. Say it is maintenance here, so you need to wait here. They don't do that. They cannot do that. Fault tolerant computers, talking about including the software and hardware. When software have a problem, like an infinitive loop, they will get out of the loop and keep working. And if a hardware has some problem here, they can fix it, or they can isolate. That portion is not working, not like everything's not working, so they can bypass here. Once they bypass that portion, you have a portion of computer software or hardware is not working, but the main portion, other portions are still working. That's called fault tolerant here. Fault tolerant here. It's not like because a small portion software hardware is not working, your entire system will be crashed here. That's not what we want to see. So you have redundant computers here, hardware redundant. Redundant just means duplicate. You have more than one, you have two. Say if you have that idea said that I have one running system, one standby system here. In case the running system is off here, the standby system will pick it up here. That's good. That's a good idea here. That you don't want to use this kind of thinking too much. Thinking about if the running system is crashed, then the stand up system has been brought up automatically brought up here, and then the startup, the stand up system, the second system also crashed. So I need the third one. If you use that kind of thinking, they're gonna say, one is crash, I use two, but two maybe also crash, I use three, three maybe also crash, I use four, four maybe also crash, so five. How many? It's good enough to let you don't worry, not worry about. So typically, if you have one system, you have another system to back it up here, we consider that's redundant. So redundant typically say that a pair, it's not like 3, 4, like 1,000 here. In reality, you have 1,000 identical system to back up each other here, and that's very, very unlikely will happen here. Using the AT&T, the STP, that's a term here, signal transfer point. That's a computer system for you to call, making phone call. If you are making a phone call from Dallas here to New York, your call, the setup may be routed to Austin, Texas, maybe routed to Tulsa, Oklahoma. That's a pair of STP to try to set up your call here to New York. In case something happened, earthquake, flood, thunderstorm, I don't know, in Tulsa, Oklahoma, it's very unlikely that will also happen in Austin, Texas here. So because that redundant system here, they are distance. One in Texas, one in Oklahoma, far, far away. So if something happened in one area, most likely may not also happen in that other area here. So they back up each other here. If you have both in Dallas here, you call it redundant. Yeah, if something happened like earthquake, thunderstorm here, we do have lots of thunderstorm here in Dallas area, wipe off both of your co-located system here. You say I have a backup here. So redundant is a backup here. Your backup is too close to each other. That's not a good backup system here. If you work for a company, you may also notice that here, they are going to have a big meeting for the directors, managers, CEOs, CTO, CRO. They are going to get together. Then the company will not allow all of them to take one plane. Maybe take 3 airplanes. In case one airplane crash here, you still have some upper management people there. If they both take one plane so they can talk to each other, sounds to be a good idea. You don't have any redundant or backup or security ideas. So it's a bad practice here. They should not do that. That's called redundant. So it's common sense here we use. CPU as, you see this as here. If you have one CPU, when one of the CPU as has some problem, another CPU, your mobile phone have more than one CPU here. So that's very, very powerful, high-tech machine comparing to your notebook. Whenever they have some new technology, they will go to your mobile phone, not to your notebook, it's a computer. Because you are carrying your mobile phone 24 hours a day, you use it a lot. In this case, they may charge you for using those new features here. So that's the stuff here. RAID here, RAID 5 here is the most famous one. So what is the RAID 5? The term you may hear people say RAID 5 here. So that's as the name tells you a lot, redundant array of independent disks, hardware. RAID is hardware here. So you have 1, 2, 3, 4. RAID offers redundant by linking several disk drivers. If you're talking about this driver back up this driver, they back up each other. This driver back up each other here. So in case hardware has some problem here, hardware they have their lifetime here. So they are going to crash sooner or later here. So once something crashes, this one to back up, this one crash, this one back up, something like that. So RAID here, system here. Another idea for the REST system here is you keep your, so it's for you to keep your info. You have info to be kept in here and here. The hardware crash here, the info here, you cannot get it. It's disappear. You still have it here. So they're machine going to tell you right away, you're going to try to use another backup for this one here, as soon as you can. They have red 0 here, 1 here, and 5 here, for different purpose, different type of backup here. This one's quick access by spreading data across several disks here. See here, several here. So if you really worry about information, at least you need to have a pair, 2. You have 3, that's fine. 4, well, that's still fine here. If you say I have 200, that's too much. That's meaning you're worried too much. That's, you're going to, I mean, very, very unlikely you're going to have this crash, then this backup also crash, this backup also crash, this backup also crash here. You need to check your hardware quality here. It's nothing to do with your redundant idea. And this one here, so stripping idea here. If one of the disks in fails here, the data is lost because it's not been duplicated on any of other disks here. So red 0 here means 0 here. You don't have any backup here. Okay, so you are not going to use the red 0 here. This red 1 here, this type contains 2 or more disks here simultaneously, right? That's what I'm talking about here. That's your red 1 here. How about red 5? The most commonly used red 5 here across several disks here. However, it has safety of redundant because this system store parity information, type of error correction. Okay, you can use to reconduct if a disk drive fails. Yeah, they can do this error correcting code here. That's very cool stuff here, because one thing here is you lost the data or the data gets messed up. That's totally different. You lost the data, you don't have it. The data gets messed up here means they have some correct info, some incorrect info. And so with this kind of idea here for red 5 here, say if certain type of info, you have info here, info here, info, you have chopped it off, like house, you have different room here. So this room 1 info here, they have error checking. They put some error code here. Once they check the error code, they know this info remain unchanged. And this room number 2, room number, if you have a very big house, you have 10 rooms here. So room 1 here, they use the error checking, figuring out here the information has been changed here. The hacker can go there and steal information. The worst is the hacker go there and change your info. Once they change your info, you still have info here, but you cannot trust the info. It's even worse than you lost it here. I mean, or as bad as you lost the info. You don't have info. You have info you cannot trust here. So they separate into 10 rooms here. So they do the error checking, said that the hacker has damaged room number 1. Room number 1, I lost a potion here. Room number 2 to room number 10, error checking message said that the information has been unchanged here. So the hacker, they don't know your error checking parity code here. It's like encryption idea similar here. Then you say that I lost 10% of my info. I still have 90%. Well, hopefully you have this backup in somewhere else. Otherwise you lost 10%, you lost 10%. But considering that, then you know, so you just divide it, so-called red 5 here. The error correction code here. Yeah, they have that, so they know safety of redundant here. Yeah, can be used to reconstruct the data if it failed here. You can be based, that's the ideal situation. You can base on that code to come back. You know that people change your info from 1 to 2, you change back to 2 to 1 here. That will make sense here. That's one way. To a certain extent, it can do that here. Scalability here, meaning if you expand here, we all consider expansion here. Say right now you have this system here, your company have 200 people. Later on your company have 2,000 people. Later on your company have 20,000 people. You're going to still use the same devices, just use more. You need more devices. Not like once you your company have expanded from 200 people to 2,000 people, then you need to get rid of your old system here, buy a new system. Then your company expand again from 2,000 people to 20,000 people. You need to get rid of those old systems to buy another new type of system here. That's not scalability. Scalability means, say for instance, you have 2 components when you have 200 people. Now you have 2,000 people, you need 10 components. You have 20,000 people, now you need 20 components. You just keep adding a component here. That's called scalability here. So scalable system can be upgraded as an organization grows here. That's growth. Talking about that here. Just add more here, not like get rid of something here. Looking for long term, you need to consider scalability here. And interoperability here, that means you get devices from different companies. One from Cisco, one from AT&T, one from Ericsson. They are all from different companies. Can they talk to each other? They should be able to talk to each other, otherwise you're in trouble here. And there are many decision makers. In this case, just choose from one vendor. We call vendor. You want to call manufacturer here? We call vendor. So I'm going to use all Cisco's devices. Cisco switch, Cisco routers, and Cisco's some other equipment here. Network security equipment here, all Cisco. Cisco device can talk to Cisco. There's no problem here. But the problem here, then you are tied up with Cisco. In case later on Cisco, I say in case, Cisco just using an example. In case this company, the product is not that good or turn out to be too expensive here, so what are you going to do? You have all this company's product. It depends on the decision here. You have company A, B, C, 3 portions of product here. In case company A turn out to be bankrupt or too expensive or quality is poor here, you just replace 1/3 of your product here. So interoperability need to be there. That's why you need to have a standard body to set up some standard. Everybody need to follow that standard. When I was with MCI, I was troubleshooting because MCI is a carrier phone company. We use products from Nortel. At that time, we still have a Canadian-based Nortel and AT&T, American-based here, and Swedish-based here, Ericsson product. They need to talk to each other. And then one time I figured out someone dropped the board. Then I, based on the standard, to say that, hey, when company A product sends something to company B product, it was handled according to the standard. But once company B's product sent to company C's product, it is not handled according to the standard. So I write a trouble report to C company here. Database here, yeah, that's information here. And database used to be not a difficult. They have a relational database or non-relational database. Everybody using relational database based on the key. Give you example, say social security number. You have your social security number, so you talk to a government agency here, they're going to ask you what is your social security number. You don't have a social security number, they cannot find you. You say you have first name and last name. There are many first name and last name just identical to yours here. So what can we do with you? Not much. And you go to a school here, they give you a student ID. Based on your student ID, again, you use your name here. They may have the same name here. But in this case, say, hey, I don't know, I don't remember my student ID. They say, how about your social security number? You do remember your social security number. They link back to your student ID. They're still using your student ID. They are not supposed to use your social security number. It's not for school purpose here, but that's they link back to your student ID. So you need a PIN number, personal identification number here in database. That's called relational database. Based on that, related to your tuition, your class taken here, your advisor here, they are all related based on your PIN number. Database here, nowadays here is about 10 years here, we have something called big data. Big data is a big idea here. So again, nothing changed here. You have data come up with, after you analyze the data, come with information. Based on the information, decision maker make decision. So that's it here. You don't want to make any decision. You don't need any info. You don't need any info. You don't need any data here. Since the data has been changed here, the way we collect data, like you use your mobile phone with the GPS, they know a lot of info. Where were you? What have you done here? They know like everything you have done. So, and many people using mobile phone, they need to have a big database here. Computer, hardware to keep those info, software to make them organized here, and certain software tools to analyze those data here, come up with info. For example, Apple want to introduce a newer version of iPhone. What are they going to do? They are going to be guessing of what kind of feature we want to put, what our customers, potential customer may like to have here. Now you base on your big data, all the data you have collected from users, your computer analyze for that, then based on the program being written by software by people here, then eventually give you some suggestion here. You want to go and guess here. That's going to be difficult here. That's your big data here. So data warehouse, just known as data warehouse here, generates information. One example is your credit card company here may sell your credit card info here. You like to buy certain type of merchandise. The credit card company know that they may sell this to another company, so they can give you more ads to buy that. Is that legal or illegal? It's based on your contract you sign with your credit card company here. Maybe legal, maybe illegal here. So data here. The pros and cons for the data here, you can thinking about the good side here is you like to buy something here, so people only try to sell you that thing here. It's not really like a waste of your time here. The con side here is you are losing your privacy. You don't have much of privacy here in terms of where you go, what do you buy, what do you like, what do you dislike here. So that's the stuff here. So they call business intelligence here. That's your data analysis here. Those people, they need to have statistics background here. So maybe from engineer, maybe from math, they need to know statistics here to do the analysis. Business intelligence. Remember we talk about expert system here. Data analysis is part of the board framework known as business intelligence here. Business intelligence here is said that based on the data, come up with some info, and business intelligence here is they are going to offer some solutions, suggestions to the decision maker. That's called business intelligence here. We find so from data to info, from info to suggestion here, info to suggestion, that's business intelligence. Then to decision maker to make a decision here. Let's take a look about this big data. It's a big deal nowadays. It's a very hot area. So we'll see here, can we learn something from the big data? See if we can.
Hello and welcome to Knowledge Hut. In this video, let's learn about what big data is and how it's classified. Let us begin by defining the term data. If you do a quick Google search, then you will find that data is defined as the qualities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. In simple words, we can say that all the facts and figures which can be stored in digital format can be termed as data. All the text, numbers, images, audios, videos stored in our phones and computers are some examples of data. They are all digitally stored and comprise of zeros and ones. Please remember that data is a plural term. The singular term for data is datum. The concept of big data is nothing complex. As the name suggests, big data refers to copious amounts of data, which are too large to be processed and analyzed by traditional tools. Since the amount of big data increases exponentially, more than 500 terabytes of data are uploaded to Facebook's database alone in a single day. It represents a real problem in terms of analysis. So you may be thinking that if this big data is so problematic, then why is everyone so obsessed about it? Well, the answer lies in the benefits it provides. Here are some real-world examples of the ways in which big data is used. Netflix collects user behavior data from its more than 100 million customers. This data helps Netflix in understanding what every individual customer wants to see. Based on the analysis, it recommends movies and TV shows which the viewer will love to watch. As a result, the customer is happy because he is getting what he likes without even searching for it. And Netflix is happy because it has delighted its customers, which will result in higher customer retention. Credit card companies collect and store the real-time data of when and where the credit cards are being swiped. This data helps them in thwarting fraud detection. Suppose a credit card is used at location A for the first time. Then, after 2 hours, the same card is being used at location B, which is 5,000 kilometers away from location A. Now, it is practically impossible for a person to travel 5,000 kilometers in 2 hours, and hence it becomes clear that someone is trying to fool the system. These were just 2 examples. Big data has hundreds of different applications in hundreds of different fields, be it banking, communication, healthcare, media, advertising, manufacturing, transportation, and retail. Big data can be used everywhere.
Yeah, I want you to pay some attention to that here is, yeah, you can say that this one here is big data here, and Netflix here. So based on many people see that, you want to see that here. That's big data. 100 million people like to watch this, so you may want to watch that. That's big data here. You have so many analysis here. And the second one here, credit card here. If you're using your credit card in here in 2 hours here, some other people, the bad guy using there, that's not really big data here. Well, that's just a simple check here. So, but if you want to consider the big data, it's not based on majority of to analyze here. That's even we don't have so many people using so much of info to collect, that still exists. This is not really the best example for big data here. That's as long as, say, we only have a couple of people who have a credit card here, they have that kind of info here. So this is not really based on big data. Just too many people want to use a credit card here. So you really have lots of info, and to analyze those info, it's existing existing database application. It's not like big data. Big data keeps supporting this kind of idea.
To travel 5,000 kilometers in 2 hours, and hence it becomes clear. Healthcare, media, advertising, manufacturing, transportation, and retail. Big data can be used everywhere, and this is why more and more businesses are trying to harness its power. Classification is essential for the study of any subject, so big data is widely classified into 3 main types, which are structured, unstructured, and semi-structured data. Structured data. Structured data is used to refer to the data which is already stored in databases in an ordered manner. It accounts for about 20% of the total existing data and is used the most in programming and computer-related activities. There are 2 sources of structured data, machines and humans. All the data received from sensors, web logs, and financial systems are classified under machine-generated data. These include medical devices,
Yeah, I'm going to stop here. If you like to see this video, you can type in under the YouTube big data and try to find it and to view it. The remaining of the video, I just want to stop here because big data, the basic idea is there are lots of info, lots of data here. What kind of tool can you analyze to come up with something here? Like collect all the info to come up with a new product here, new phone, new car here, or try to profiling here. The policeman using this term here, profiling here. So that if something happened here, you want to see who's the bad guy. If it's a murder case here, use the big data to try to figure it out. Then they tell you, based on everything we have, that maybe person A or B or C or D have done that. Then that will help you. That's try to investigate some starting point here. So that's called big data here. We find here, yeah, so that's your big data here. Say we move this guy here, we hide this guy here, we come back this guy here, come to here. So that's called business intelligence, that's big data. It's a big deal nowadays. We use the big data to do a lot of stuff here, new product here, or analyzing the problem here. Data mining is the different term here. Discovery of new pattern or relationship between data, data mining here, That's based on you realize the mining here. You can say that, say, I'm doing a data mining. I say, hey, iPhone user here, they are generally from age 20 to 30, most of them. That's called data mining. You find a pattern here. So you may want to focus on this area. That's data mining here. They even mentioned social media. Yeah, social media is a big deal here. Nowadays, you have journalism, you have ABC, NBC, CBS, and even bigger one called social media. Maybe YouTube, maybe Facebook, maybe Twitter here. They are the biggest media, news media nowadays here. And there are many people here, unless that's a fake one or manipulated here, they are expressing many people's idea here, more than thousands, millions people's ideas. So think about big data, think about social media. You really need to, you have too many social medias info here, so what are you going to do? You are going to use the big data to analyze here. And with the business intelligence here to some fake news here, redundant. Some people have posted 1,000 times. You're going to count it as one time, not 1,000 times, because that's like same idea. Data validation here for information here. Yeah, data validation here. You have verification and validation here. You want to know the data is a good data here. We have many surveys here. Since day one, we have surveys. Some surveys have too many questions here, say 50 questions here, then they make some trick question or checking question, like question number 1, they ask you something. They come back to question 25, they ask you the similar or even identical question, see if your answer. If your answer are totally different here, they are going to dump your survey here because you're not really do a good job for your survey. You probably just save some time, go there and all pick 1, 2, 3, 1, 2, 3, 1, 2, 3, who knows here. And this one is also zip code here. They want to do a survey for zip code, say 75203, what people thinking about that. They based on your big data info, they know you have some info that you are not local here. They're not going to take your survey because this is wrong here. You're not in here. I mean, maybe some people for some purpose just trying to manipulate the info here. So data validation here, they all come with that here. One typical information is your credit card. You're going to use your credit card. They're going to make sure no one is crediting your credit card here. Yep, I'm going to stop here for what I would like to talk. And